Welcome everyone. I'm Sudipta, the chapter chair for IEEE NSW Education Chapter. Uh, Welcome you all for today's workshop on exploring engineering laboratory objectives, learning and assessment, and open discussion of laboratory implementations during COVID, which is very much related to what we are going through now. We have two speakers today, Dr. Sasha Nikolic and Dr. Faisal Tubal. Dr. Sasha Nikolic, he received his PhD in engineering education from University of Wollongong. He is a senior lecturer at the Faculty of Engineering and Information Sciences Education at the University of Wollongong, where he is also a fellow of the Wollongong Academy of Tertiary Teaching and Learning Excellence. Dr. Nikolic is currently head of students for undergraduate engineering. He previously worked as a laboratory manager at the same university and spent several years in industry. His interest is in developing career-ready graduates involving research in teaching laboratories, industry engagement, work-integrated learning, knowledge management, communication, and reflection. Dr. Nikolic is a member of the executive committee of AAEE and an associate editor for AJEE and EJEE. He has received several awards, and he is currently secretary of the IEEE Australia Council and editorial board member of the IEEE Teaching Excellence Hub. He was co-chair of IEEE TALE 2018 held in Wollongong and serves on the IEEE TALE steering committee. It will be a joint presentation from Dr. Sasha Nikolic and Dr. Faisal Tubal. I might as well go through Dr. Faisal's biography as well. Dr. Faisal Tubal, he received his PhD degree in telecommunication engineering from University of Wollongong in 2017. He joined the University of Wollongong as an academic assistant at School of Electrical, Computer and Telecommunication Engineering. In 2019, Faisal was promoted to the position of laboratory manager at the School of Computer, Electrical and Telecommunication Engineering. He is author of three chapters and several conference and journal articles. His research interests include antenna designs for CubeSat communications, wearable antennas, and antenna designs using metamaterials. Dr. Faisal was the recipient of the Vice Chancellor's Awards for outstanding contribution to teaching and learning. He is a fellow at Wollongong Academy for Tertiary Teaching and Learning Excellence.
Thank you, Sudipta. So it looks like we have a very New South Wales audience today, someone else from Australia and someone international, which is great to have everybody on board. Yes, so myself and Faisal, we will be presenting today, and it's a pleasure. This is what we're going to be covering today, and I don't really want to be speaking too much. The main purpose of today is to really have a conversation going. But what I am going to do is just go over a little bit of theory of some laboratory objectives and some assessment tools used to put into a little bit of perspective of the types of things that we could be thinking about when we do have that open discussion at the end. So what inspired this presentation? COVID has helped accelerate the implementation of different lab modes and approaches. Those who were already doing remote style learning practices were well ahead of the curve here, and the implementations really were able to shine through. For the rest of us who were dealing with traditional type labs, we really had to quickly jump ship and try something else. So what I wanted to do is, while we're undertaking this change, I want to reflect on what are the laboratory objectives to make sure that even if we do change short-term or long-term, that we ensure a balanced approach across the degree is occurring. So we need to think about different modes, and here are just a few different modes that come to mind. And one is what most people would be familiar with, which is include your traditional, which is your face-to-face. Other modes include simulation, recorded, virtual, remote, and so forth. And every mode has different advantages and disadvantages. I myself am for all modes, and I in particular prefer to do mixed modes, because I found through my own research that the different modes do have great advantages, and if you combine different modes, those advantages can be strengthened and those disadvantages can be weakened. So back in, I think it was 1992, some colloquium was held to determine what are the laboratory objectives, what are the core laboratory objectives. And the reason this colloquium was held and these objectives created was that the transition from face-to-face to other modes of teaching, such as simulations, recorded, was starting to become more prominent. And people wanted to work out, all right, how are we going to compare the educational differences between those two modes? So they came up with the following 13 core objectives, which cover instrumentation, modeling, experimentation, data analysis, design, learning from failure, creativity, psychomotor, safety, communication, teamwork, ethics, sensory awareness. So when you have a look at these 13 objectives, you can see that the laboratory is a fantastic learning medium for our students. Now, for those that aren't aware, but I assume everybody is aware, learning can occur across 3 domains as outlined by Bloom's taxonomy. And the first is cognitive domain. And if we look at our typical engineering degree that uses that real traditional format, final exams and other paper-based assessments excel at assessing these skills. This includes knowledge, comprehension, application, analysis, synthesis, and evaluation. What the lab sessions excel at and are well known for are the psychomotor skills that you gain, the ability to imitate, manipulate, perfect, articulate, and embody. However, assessment tasks that directly assess students' ability in the psychomotor domain are logistically much harder to do. It's so much easier to get people doing a written test and marking that than observing and recording their psychomotor capability, which I hope to be proved wrong later on. But let's just keep that in mind. The affective domain is also something that laboratory sessions are just as good at, but less associated with. We really don't think about measuring and assessing effective learning that is occurring in the laboratory. Again, many of the assessment tasks concentrate more on that cognitive domain. So something that's very important to note, even though we talk about the 3 different domains, all 3 domains cannot be isolated from each other because almost all learning activities involve more than one domain. And that is something key to remember as I go forward in this presentation. Now, what I would like to do is quickly ask the audience. Oops, not that one. Which learning domains do you target in your laboratory assessments? Okay, it looks like everybody has voted. Let's share those results. And as you can see, cognitive comes out in first place, psychomotor in second, and affective third, which reiterates what I was trying to say. And I'm really pleased that many of the assessment tasks are, in fact, showing the psychomotor and affective domains, and that's slightly higher than I was expecting, which is fabulous work from everybody involved. So how has this research continued? Salim went through and they took the 13 laboratory objectives created by Faisal and Rosa, and they took that and created a survey instrument that divided those objectives across the cognitive, psychomotor, and affective domain. Now, this instrument was used in a single purpose environment for an electronics laboratory. So what I did with my research team is we built upon the work of Salim and we created the laboratory learning objectives measurement tool, which takes that previous instrument and modifies it in a way that it could be used in any laboratory environment. And it's available on IEEE Transactions on Education if you wanted to read it in more detail. But the core of it is that there's a whole bunch of statements on there that look at the whole spectrum of laboratory learning objectives in a self-assessment type format. And the idea is into the future that these can be translated into assessment tasks so that we're measuring all forms of learning that are occurring at the laboratory. And here are just a list of the different types of learning that we're looking at. Now, real learning versus perceived learning is extremely difficult. Cognitive is the easiest to measure real learning because it's just so easy to do a quick pre and post paper online test. However, psychomotor and affective are much more difficult because it's not as easy to take the time out of a lab class to measure, all right, what is your ability to learn from failure right at real one compared to at the end of week 13. You know, if it's just a survey question, that's easy. Here, how well do you learn from failure? At the end, how well do you learn from failure? I can easily do that. But to actually sit there, observe, mark, it is much more difficult. So that's why we started with just looking at perceived learning. How do students perceive they are learning across all the 3 domains? So what we wanted to see is the multi-domain laboratory learning on student evaluations, and to see if multi-domain laboratory learning is being perceived by the students. So what we did is we set up in experiment 1, students undertook the LOM survey, and then they conducted all the various experiments. And on the last experiment, we conducted the LOM instrument again, and we undertook a student evaluation. So perceived learning is the difference between the initial survey and the final survey. And students were rating their ability of each survey measure at the time. Now, one advantage of using the laboratory for this tool compared to the traditional format, where we have one lecture class and we get have multiple teaching staff, demonstrators, tutors. We have one set of data we want to compare across years to see did a change occur. What happens is we have slight changes in the delivery each year. We have different noise from the subjects. Who is attending and evaluating is difficult. Not all students come to class and so forth. But the advantage that we had using laboratories is that we could use a multi-level model where we could link survey results at the student level, the lab class level, and at the course level. So we could compare data from course to course. We could compare between laboratory classes, and we can compare the results across demonstrators. And more particular, if there was a very large class with lots of lab classes, if a demonstrator taught multiple classes, we could compare the data across multiple lab classes, their performance, to see how it changed. So it allowed this really in-depth statistical analysis to occur. And what we found out, and we did this study in both University of Wollongong in Australia and the University of Belgrade in Serbia, and we found out using this multi-level analysis is that students perceived that the laboratories provided substantial learning benefit across all domains. Now, we were actually able to split the cognitive domain into two components. One is the analytical skills and one is written skills. And this is how the factor analysis played out. So you can see it's consistent. So while, if we look at that survey, pretty much 100% of us were using assessment tasks that measured the cognitive learning, and it was down to what was a 50% to 40% across psychomotor and affective domains. We were only, in essence, measuring a part of the learning benefits that are occurring from our activities in the laboratory. And one thing to mention is that in Wollongong, we are very traditional based, and we had this learning occurring, while in Belgrade had much more simulation and remote type implementations. And even using these different modes, psychomotor and affective learning still shone through, which is really impressive to see. We also were able to look at the relationship between the perceived learning and how they were evaluating. So here we see how they evaluated the experiments. This is how they evaluate the facilities, and this is how they were evaluating the demonstrators. And this is the various learning domains. So what we have here in these figures is the relationship of an increase in this survey score in relation to the learning domain. So for every one increase, the score would increase by 3.5590, well, expected to increase. And as you can see, very statistically significant across all three domains. So what this means is if a student is satisfied, they're not just satisfied by their cognitive learning, but they're also portraying in their evaluation the satisfaction in terms of what they perceive they are learning across both the psychomotor and affective domains. Now, I can say that is true for Wollongong, but if we have a look at the University of Belgrade, we didn't have the same effect across all of it. So it kind of shows that student evaluations in what we know is really comes down to the institution itself. You can't talk about survey results and place it to a wide spectrum. And we have a few reasons why we believe we had a lot of similarity here, but not in this area here. And that is primarily because the facilities at the University of Belgrade were pretty static. The students didn't have the variety and the depth of equipment that we had here in Wollongong. And also in the demonstrator scores, we believe this came down more towards cultural differences. But the key point out of this is that learning across all domains is important, not just the cognitive. And as engineers, especially for our assessments, we're kind of forgetting that. And to look at that a little bit further, so this is just what I was talking about. So across both universities, perceived learning is happening across all three domains. Students are gaining lots of skills, but the question is, are we assessing and valuing all of them? And student evaluation scores are being influenced by multi-domain perceived learning. Do we value this appreciation when trying to improve evaluation scores? Now, if we look at the assessments and how this translates, what we did is a systematic literature review. And we looked at what people were publishing in top quality journals, and in particular, new laboratory implementations. So somebody designs a new laboratory and they want to work out, how successful is this new laboratory implementation? So we looked at what assessment tasks they were using, or they talked about as being implemented in the subject, and then which were they actually using to evaluate success in the lab. So as you can see, there's a huge range of different assessment tasks being used, the most popular being the lab reports. But the problem was that all the success factors of the laboratory were being targeted at the cognitive. So 16 out of 16 were looking at cognitive objectives. When we look at the psychomotor, only 2 assessment tasks that factored in psychomotor compared to 9 were actually being analyzed, and the same for affective. So while people were implementing assessment tasks that would measure these, success factor was only being driven by cognitive. And this is something that I want to change. I want us to be able to appreciate the learning benefits across all modes. We need to gain that deeper appreciation of all learning that is occurring in a laboratory. So we also took that systematic literature review a little bit further, and we looked at published studies that compared laboratory modes. So again, we had quite a variety of assessment tasks. And again, when finding out how successful the change in mode was, 10 assessment tasks were used to measure the cognitive, and 10 were used within the data analysis to determine how successful it was. So 10 out of 10. When we look at the psychomotor, 8 possible assessment tasks were available, but none of those assessments were used to measure success. And for affective, we have the ratio of 2 to 0. So again, this is something that I want to highlight. Now, learning could be happening here, but I guess the difficulty is that it's much harder to measure real, as I mentioned earlier on in the presentation. Now, I have to put a caveat to this, is that a lot of the psychomotor and affective benefits of such modes were being measured simply by a student survey. And on balance, the student surveys were showing that, yes, psychomotor and affective benefits were occurring within the various different modes. Now, the challenge that I'm putting to all of you who seem to be interested in labs is like, how can we take this survey data that we have and translate that into using real assessments to confirm that, these different modes do have psychomotor and affective learning benefits, just not only the cognitive. So what does this mean? Why is it important? So we really want to make sure that we understand that the laboratory is a multi-domain learning environment. And we want to push further our understanding, especially when we're comparing laboratory modes. Now, the question I ask to all of you is, as we move away from our original laboratory setups for COVID, some may be temporary while others permanent, are we still considering the multi-domain impacts, both positive and negative? As we can see, when we're looking at research, when we're going to do research, we're focusing on the cognitive. When we're doing the switch and we're working out, were the changes beneficial? Are we looking across all domains? So what we have now is an example of implementation from the University of Wollongong. And Faisal Tubal, he will go through and talk about what we did at the University of Wollongong. And this will be a launching point for everybody else to come in and tell us, what did they do during COVID-19? How did the implementation occur? What worked, what didn't? And what impact did you see on the multi-domain learning that was occurring in the laboratory? So Faisal, you can tell me when to put forward, or we can change the sharing if you'd like.
Yeah, that's fine. So if you want to change the sharing, can I control it from here? I can't. You need to give me. Yeah, I can. Is that right?
Can you?
No.
No. All right. So I'll just do this. I'll do it for you.
Yep.
Just tell me when.
Or I can share mine from here if you want.
Okay, I'll stop the share.
Yeah. Can you see with me now, this slide?
Yeah.
Right. Thank you, Sasha, and thanks, Sabita. Um, um, Regarding during COVID-19, so the change that we made at the University of Wollongong and the challenging we faced is how when the pandemic started, the COVID-19 pandemic starts, is the challenging was how to run the hardware-based laboratories remotely, like how to change it to online. One of the ideas is to let the lab administrator share the hardware with, let's say, 20, 25 students. So, but we found out that the interaction, it will affect the interaction time between students and their lab administrators, and also it will limit the communication channels between students and their lab administrators. So the idea we came up with and we implemented is to run a mixed mode delivery for the hardware-based undergraduate engineering laboratories. And as a case study, we have a subject for first year student engineering students. We had more than 350 students for that subject. And when I said mixed mode, I mean both online and on-campus students will run the lab at the same time. So the idea is, we're going to talk about the structure and setup. The idea is to use the Zoom session breakout option to help us to divide each lab in two sections. So one part has only, let's say, half of the class is on campus who are running the experiment at university here, and the other part are attending the lab remotely at the same time. Then those students, online and on-campus students, will be sent or were sent to a breakout rooms. Each breakout rooms will have one on-campus students with one online students. We also assigned two lab demonstrators, online lab demonstrator and on-campus lab demonstrator. In this case, we had more than one communication channel, so students can communicate with each other in each room, and they can communicate with their both lab demonstrators as well. And that will improve the interaction time between students and with their lab administrator. The main advantage of this, that the online students will be able to watch their peers, their on-campus peers, while conducting the experiment, and they can interact with them, and they will be doing the same experiment using multisim. So the online students will run the experiment using the simulation, then they will watch the connection of the hardware with their peers, then they can share the results and discuss that using the Zoom. So let's show you what we have done. First of all, the setup of the room. So we consider it the 1.5 meters between students, and we provide the hand sanitizers. We have a cleaner that comes before each lab and clean up all the surfaces, keyboards, mouses, make it all clear. But also we provided a wipes to our students, so to feel more confident, they can clean up by themselves as well. We use it for each bench. We have a webcam. So each student on campus students will have a webcam that needs to use. Then at the beginning of each lab, we will have on-campus lab demonstrator, and we will have online lab demonstrator sitting somewhere in the same room at the corner. And we have on-campus students in this room. We have about 18 students. And we had 18 students attending the lab remotely from different places in the world. As you can see at the very beginning, the on-campus lab demonstrator, everyone will log into the Zoom. The on-campus students, they will log in the Zoom. Online students, of course, they will attend using the Zoom. And the online and on-campus lab demonstrators will attend the Zoom session. Now, the on-campus lab demonstrator will run 5 to 10 minutes introduction to all the students, everyone in the main session, in the main room of the Zoom. After the lab demonstrator the on-campus lab demonstrator finish running the introduction, the online lab demonstrator will send all the students to their breakout rooms. As I mentioned before, each breakout rooms will have one on-campus students, one online students. Now, then this photo here shows the interaction between the on-campus and online students. So we had online students here and on-campus students. And as you can see, using the webcam, the on-campus students share all the connection, the hardware with the online students. So the online students had the opportunity or had the chance to watch the connection. And actually, they also interact with the on-campus students. They ask, why you connect this one? Can you show me again? And they can share the results, the obtained simulation results with the measured results in here. During the session also, the on-campus lab demonstrator will start walking around the room and helping the students and answering their questions. Now, while the on-campus lab demonstrator answering the questions, also he can answer the question from the online lab demonstrator, because the online student is also listening to the conversation between the on-campus student and on-campus lab demonstrator. Also, if he or she has a question, they can ask through the on-campus student. The online lab demonstrator will be sitting at the corner using the computer. He will be, or she will be, visiting different breakout rooms, looking for students if they need any help or if they have any questions. He will be communicating with an on-campus student, and he was also communicating with the online students. So he provide the communication or provide help for both of them. In this case, now when the online students had a question, he normally, even if the online lab demonstrator is not in the same room, he can ask for help. So the online lab demonstrator, he will be notified, and if he's just checking the other groups, he can go back to that room and help out. And if he's answering other groups' questions, after he finished the question, he go to that room. Or otherwise, the on-campus demonstrator can also help for that online students by going physically to the bench, then talk to the online students, or can listen to the question through the on-campus student. To measure the effectiveness of this mode, which is a mixed mode delivery, we run a survey. We asked students different questions, and we found their feedback. So I'll share you with feedback. So first, there are questions were asked to both online and on-campus students, such as we asked about their satisfactions regarding the mixed mode itself, like being paired with online or being paired with on-campus students. As you can see, 88% of students were satisfied with the transition from to the mixed mode delivery. The other question was asking them about if they feel safe, especially for the on-campus students, if they feel safe with the social distancing, because some students they had concern. For example, that's why they didn't come to the on-campus about the social distancing. So when actually we took all the measurements, we made sure everything is according to the COVID-19 plan. And from the survey, we can see 95% of the students felt safe by implementing the social distancing. The other question was asking them about their satisfaction with the level of communication with their lab demonstrators. As we can see, 92% were satisfied with the level of communication, because students instead of communicating with only one lab demonstrator who is dealing with 20 students at the same time, it's not as when you are communicating with like all the time with one on-campus students, and you can also communicate with two lab demonstrators. If the online is busy, you communicate with the on-campus and vice versa. We also asked questions for all the online students, looking for their satisfaction regarding the interaction time with their on-campus peers. And we found that 95% of the students, they said that they had enough interaction time with the on-campus student peers. We asked also the online students about their interaction time with the online demonstrators. 90% of them indicated that they had enough time, interaction time with the online demonstrators. Now, we also asked the on-campus students about their satisfaction regarding the interaction time with the online students. And also it shows that 95% they were happy with, they said they had enough interaction time with the online student. We asked them also about the interaction time with the on-campus demonstrators, and it shows 97% of students indicated that they had enough interaction time with the on-campus students. We had also received some written feedback sent by students. As you can see here, for example, one of the students said, the idea of being paired with or grouped with a person on campus who is physically completing the experiments makes me, as an online student, feel like I'm there participating. This was really a good feedback as well. Also, students, they mentioned that that they received a support from the lab demonstrators and also from the on-campus students, and they said that the response for their questions was really quick, so they don't have to wait. This is really a good indication. And students, I have heard one of the students who was doing the on-campus, was doing the lab on campus. He told me he was struggling with the connections, and his pair, the online students, helped him out to find out where is the problem was in the connections. So that shows that it was all right. Also, we compared the lab performance with previous years when there was no COVID-19. This subject that we run it was run in the spring, and we know COVID pandemic started in autumn 2019. So as you can see here, in 2018, where we had about 400 students, the lab performance, and it was only on campus. All the labs were run on campus. And the performance was 84.6. In 2019, also all the labs were on campus, and we had about 407 students, and the lab performance was 93.3. While during COVID-19, when we had the mixed mode, when we run the mixed mode, the lab performance was 87.6, which is all right as compared with the previous year when there was no COVID-19. Of course, there's always a limitation and challenges. One of the limitations that the internet connection problems from students' end. Sometimes students attend the lab late, some few students, because they had a bad internet connections. Some of them, they drop out the Zoom session during the lab, and it took them time to rejoin again. And that was one of the limitation and challenging as well. The time differences between Australia and other countries, such as China or some countries in Middle East, India, and so far. Sometimes when it's evening in Australia, it's too early in other countries, and it's all too late in other countries. So the students, they attend late as well, and that was a challenging in terms of their performance. Keeping online students engaged and contributing is a challenge as well. You know, when you're dealing with someone behind the screen, sometimes they're not. You have to make sure they are really engaged in the. So we had some issues, a few issues with this one as well. The other thing is the hands-on experience. Of course, watching or someone doing the hardware is not like when you're doing it, getting you there when you're doing the experiment by itself. So that's the thing they are missing. It's not like when you're doing the thing by yourself, not like they're watching it. One of the ideas, if in future work, maybe if the lab has low risk and like it's low risk for the low risk experiments, maybe a lab kit that includes all the required components can be sent by universities to the overseas students, can be posted. Then students, while attending this mixed mode, they can implement the circuit from their end and compare their measurements with the on-campus students and discuss it with the lab demonstrators. That's all. Thank you very much, guys, for your attention.
Thank you, Faisal. So what about assessments? Were any of the students disadvantaged?
Yeah, I forgot to mention about the assessment. Thanks, Sasha, for reminding me about that. The big challenging, I should mention that one, I forgot to mention that, was the assessment, especially for the online students. Because, you know, the online students, they copy the measurements from the students who's on campus, but they're not doing it by themselves. So what we did, we mark the online students according to only the simulation results. So we don't punish them for for getting the wrong measurements, for example, not like the on campus. So and that's one of the that's the thing. So they were assessed on their simulation results only for the online. For the on campus, they were assessed on their simulation and measurement results. But the online lab demonstrator was marking the online students. The on-campus lab demonstrator was marking the on-campus students. Students who were online, most like it was all good. Maybe few students, like maybe 4 or 5 students, who claimed that, for example, they are attending the lab using the mobile phone. So we told them that they have to attend it using computers. That was at the very beginning. So then they did the work, then they send it by email, then the experiment after they start using the computer, because they have to run the simulation and they have to share the screen with the lab demonstrator to see or assist their simulation work and give them mark for that.
Were you able to analyze the data between those online and those face-to-face to see if there was any difference in the learning outcomes?
In the performance, no, that's a good point as well, to compare between the online and on. Yes, but we just the lab performance was for both of them, on campus and online. But I think maybe that can be done as well to find what's the performance for the online and see if the online students were affected by this transition or not.
Okay, I'm sure when we move on, people have lots of questions for Faisal. So let's just change to the next slide.
Yeah.
Oh, back one. All right, so here's a little sneak peek preview while I have everybody's attention. I believe it's next month. The IEEE is launching the IEEE Teaching Excellence Hub. It is going to be a portal where everybody can contribute teaching practice solutions to the community. So this is not research articles. This is not articles that will be indexed anywhere. It's simply simple ideas, practical ideas of how you can, undertake different teaching implementations. So, here's a little sneak preview. Look out for your IEEE email to tell you about this when it is launched. I will put a link to this on the IEEE New South Wales section, LinkedIn and Facebook pages when it officially launches. Okay, next slide. So now it's time for you to share and to ask questions. Tell us about what the impact was for you. What changes did you have to make? What changes, if any, did you have to make to your assessments? Think about the learning objectives discussed today. what were the holistic positive and negative learning impacts? And how has this experience changed your viewpoint on laboratory modes going further? So what I will do is I'll stop the share.
Okay, I'll stop it from my end.
Yep, and we can all see each other. View, gallery view. All right. If anyone would like to ask Faisal some questions or myself, go ahead. But hopefully someone can share their experiences with the guiding questions that I just asked. If no one wants to share, I'm going to put one out to David. David Lowe, if he's on the call, not busy at the moment. How advantageous was remote learning setups of yours during this period, David?
Hi, Sasha. How are you?
Yeah, good.
Not very, was the short answer. It should have been, but it wasn't really. Josh might be able to add into this as well, but I think it was a combination of academics, anyone who was going to use remote labs was interested in them already had, or already was, which wasn't that many people. Those who could have benefited were too busy just running to get everything else online. And, I'm sure everyone kind of remembers what it was like at the beginning of last year. COVID hit, everyone was frantically saying, holy crap, how do we manage this? We've got to move all of our teaching online. And that meant coping with a huge raft of other logistics. And I think a lot of people just said, labs, how do we deal with them? We could, park that while we deal with everything else. I think the closest a lot of people got was to say, well, if we can't get students onto campus, building remote labs, no, that's too complex and difficult and it'll take too long. I know, we'll just get a camera and go in and record the video, video of the lab, of me doing the lab, and then put that online, give students the data and let them deal with it. So I think it was largely a consequence of just time pressure. So if anything, it actually made remote labs more difficult because they take time to develop and manage. In many respects, I think it would be nice to think there was an opportunity to trigger people to think about their labs, because they were, it's interesting, in lots of other areas of people's teaching that were impacted by COVID, I do think there was a sense that people it triggered them to at least think a little bit more about what they were teaching and why and how, because they were moving online. And so I saw that in some areas. I didn't see a lot of it with labs. And I think that's probably a reflection of the fact that kind of, for many people, labs are just the background bit that they've been doing for 30 years, or 20 years or 10 years, and that you do it because everyone does it and it's expected. And so I don't think I saw the same level of triggering of kind of thinking about why you'd use labs as I would have liked to have seen, or that I saw in other areas. I don't know. What about anyone else?
Carla, you're on mute.
Hello, everybody. Some of you already know me. I know David may remember me. I'm Carlo Manfredini from Emotor Instruments. And for those of you who don't know, we make remote access labs where students can control remotely across the internet an electronics lab to teach telecommunications and
really good, well-designed kit.
Yeah, and since we were interacting, David, we've made some new things. But to address the question specifically, I've got a quote from a professor in New York, from CUNY. He says, The students are engaging with the remote hardware in a way that I would not expect for a simulation experience. I am glad that we were able to arrange this experience for them. And my department head and I have begun discussing how we might integrate remote hardware labs into our future curriculum in future normal times.
Yeah.
So that's one reply we've had, and we're in hundreds of universities around the world. But I'll be honest, over the last year, I would have expected the door to be busted down by people saying, can we buy your equipment? They haven't busted the door down to buy it, but there is some momentum building in the marketplace in many different countries, specifically India, the United States, the Middle East. They're our main markets. So I can't put a figure on how much interest there is, but it is building as people think. And the attitude they're saying is, we want to go back to hands-on learning, but we need this in the background just in case we have another burst of COVID or we have to shut down. That's one response. The other one is, we're getting some pretty good value out of this remote learning stuff. Students can work at night and the students quite like it. So that's feedback from the marketplace. And the students enjoy the hardware more than they enjoy simulation.
Can I ask you, was the New York comment related to the use of TIMS?
No, it's related to the use of our remote hardware, called FreeWire. In the last couple of years, we've taken TIMS, which is a telecommunications modelling system, and we've automated the, it's like NetTIMS, David?
Yeah.
But it's actually better. We've got a new one called FreeWire, where you can make all the interconnections between the modules and control the knobs and switches. It's exactly the same as being in front of a box of telecoms equipment, but you're doing it across the internet. So that's quite interesting. We do that with analog and digital as well. But what we've done that's new, and I think this is going to perhaps impact the market, I call it the market, sorry about that, your colleagues or whatever, differently, is we now, our boxes sit on the internet, so you have to buy the box and put it in your lab so your students can use it. But if we have a farm of these boxes in our office, universities can access our farm remotely and not have to buy the unit. So we're now offering what we call hardware as a service. So you can subscribe to our server farm and have access to the 5 or 6 different labs remotely without having to own the equipment, and you can pay month by month. So I just want to put that out there as a model that I think will mean universities that only want this for 3 months a year, or universities who just have an emergency need for this technology, can just sign up to a subscription. So they don't own the hardware, they subscribe to the service, but the service is real interactive hardware, real hands-on learning. And it's also multi-user, by the way.
Yeah.
Multi-user. So that's my experience. Obviously, we had a lot of feedback from clients around the world, but generally, I have to say, students really dig controlling something more than they like playing around with simulation. That's what we've found.
I think one of the problems you had, Carlo, was that while everyone would have wanted to spend the money, all the budgets were slashed,
Exactly.
and all being spent on Zoom licenses and not enough spent on other licenses, such as your software.
Yeah, that's a really good point.
Yeah, that's right. And look, in due course, I think the budgets are opening up, and we're actually quite busy now. Sure, things were quiet back in March, but now things are picking up. So that's just the reaction we're getting as we put out some different options out to people.
We're using TIMS for our communication lab. It's really great. We are using the TIMS online software for our communication lab here at uni.
Yes.
And it's like we have been using it since last year. So, and we're using currently now this session, and it's really perfect. It's really good.
You're talking about our simulation tutor team?
Yes.
Yeah. So as well as tutor teams, which is a pure simulation, we have real hardware that you can control remotely as well. And sometimes people say to us, why bother? Simulation's just as good. and this is something people have been saying to us for 20 years. And the response that we give them is that we've found that students, when they make a mistake using real hardware, they look into themselves and they ask themselves the question, what am I doing wrong? So it goes back to that cognitive, psychomotor and affective learning domains. They question themselves. But when they make a mistake on a simulator, all they do is click more frantically until they get the right answer. That's what professors have been telling us.
The other thing also, because in here what we do, we run the simulation and the lab demonstrators, they run the experiment here. The simulation gives you the perfect results. Okay. And the measurement there is like, but that's obvious. That should be like this. But it was really close enough.
Yeah, you're exactly right. Back to this learning domain stuff, you know, hands-on learning is the best. We acknowledge that. Everyone acknowledges that. We just make different options so people can, you know, horses for courses. So cognitive, that's pretty straightforward. Psychomotor, it's great to be doing something and students really like that. And affective, how do they feel when they've achieved something with something real? You know, they feel really good. So
the challenge that I bring out to this group is that we can perceive that is the case. And I'm pretty sure that what you're saying is right, Carlo, but we haven't got enough evidence, empirical evidence out there in the community to back this up. So the call is to the community listening in onto this podcast, this cast, is that, you know, let's try and do some empirical experiments to go beyond doing the cognitive, what we're always studying all the time. And let's see, how does remote labs, you know, with the proper assessments, bring out improvement in learning in the psychomotor domain and the affective domain. If we can collect that data and have it, it will change the landscape a little bit on opening people's minds up to multiple modes of laboratory learning.
Yeah, and I think a lot of our potential clients are very concerned about how effective it is as a teaching mechanism. And so, yeah, those kind of studies would be really worthwhile to open up, you know, this as an option. And if people want to work with us to do some case studies, please contact us, and we're always happy to do that. You know, if it's helpful, you know, it's useful for us to have case studies as well.
Excellent. What about somebody else?
I have a few questions to Faisal regarding what he's told us today. I would say that it was really fantastic idea, like, you know, this online and on campus, like half online and half on campus, because what we have been doing at Macquarie for the labs, they were all online. It wasn't half and half. So I found it quite interesting. I have a few questions to start with. You said that there would be one student online and one student on campus. Now, did you ever, I was thinking, like, did you swap this group? Like, you know, the online students maybe next week would get a chance to come on campus and vice versa, so that, you know, everybody gets a chance to do some hardware stuff and simulation. But also towards the end of your presentation, you mentioned, and I realized that you were considering that there were international students who were stuck overseas, who are not here. And therefore for them, coming on campus was not an option. But the students who were here, so did you give them a chance to kind of rotate?
Thanks for your question. As you said, for the online students, we have two types of online students. We have online students who are in Australia here. Let's say even Wollongong or close, and there are some online students who are like outside Australia. For outside Australia, there's no option for that. For the students who are in Australia, we told them that if you wanna to be on campus, it's not swapping, because students who were on campus, they don't want it to be online. So we were not able to swap, but we offered them a spots on campus. At the beginning of the session, like lab 1, from lab 2, we start receiving emails from few students showing their interest to be on campus, and we provided them spots on campus. We had also, like, we had more than 10 lab sessions. We have about 362 students enrolled, mixed, both of them. So we had one lab was completely on campus. It's not, all other labs were mixed, but one lab will only all on campus. For those who were moved, who wanted to be moved from online to on campus, yes, they were over it, and some of them they changed it to, most of them they changed it from some of especially those closed to on campus, and they were running the lab by themselves, not paired with the online students. Then maybe you ask me, what about the if he was paired with someone on campus, then that on campus will continue running the lab by only himself with no one else paired. We have also few students who wanted to be moved to online. And because some students, they get a job, let's say in another state or somewhere else which is far away from university. There were very few, but they asked to be moved to online, and we moved them online as well. So we were flexible in that.
Yeah, that was my next question. I was thinking, like, how did you divide the group, this online and on campus? Was it like, did you do a survey where students expressed their concern that they don't want to come on campus because of COVID? They did not feel it safe, and you chose them. You allocated them to the online group, and whereas the others who wanted to come, you just allocated them to on campus. Like, how did you divide this group?
Oh, thank you. In the SMB, on the SMB for the enrollment, we offer two options, two type of enrollment. So we have lab session, it's called online only session, on campus only session. So we divide them half. Let's say we made 8 labs. Each lab capacity was 18 students for online, and 8 labs with a capacity of 18 students for each for on campus. Then we were watching the enrollment. Then after the enrollment finished, we matched them. Like if the capacity, because maximum capacity according to COVID-19 plan for our lab, let's say for example, it was 18 spots. Then we take 18 from on campus, we pair them with 18 for online. But when we over like lab, let's say Tuesday 1:30 online lab, 18 spots. There's also Tuesday 1:30 on campus, 18 spots. So when both of them like rolled, all the students rolled, then we mix them together at the same time. But the only difference is one online, one on campus.
Yeah, I get that. But I was like, yeah, how did you make the decision? Like which one, like online and on campus? So based on their choice.
Yeah, we had an estimate from the university for how many roughly international students we have. Yeah, then we just adjust them. Don't forget that we also run one thing I forgot to mention. We also run the labs in 2 labs at the same time. So we have the flexibility of changing the lab around to the 2 labs at the same time, changing the enrollment number. I mean, because when you change them from this room to this room, you're not gonna fix. There's no clash because they run at the same time slot.
So in the end, it was demand driven, is what you're saying.
Yes.
Yeah. And did you notice any issues? I'm sure, like, whenever there is some group activity or group task, we often hear some problems, not from all the groups, but there will be at least a few groups, who would complain that, the teammates did not do this, do that. And in this case, because one student was online, one student was on campus, and, they had to have a very good collaboration. So did you see any issues, like apart from the online students being dropped out, but I guess like the on-campus student, it's fine, but for the online student, they should be well supported by the on-campus student because they are just watching the hands-on work. So how did that go?
We had like very, very few students. I think maybe 2 or 3 cases where online students contact me, send me an email and say, look, my on-campus pair, it's not cooperate with me. I'm trying to talk to him. He's not reply to me. Sometimes there's an issue with, I don't know, with the internet, but sometimes some lab demonstrators, but when we found that one, we fix it straight away. Some lab demonstrators, they wanna finish. When they finish, they wanna leave. They don't wanna stay with to explain or to share with the online. But some students, like as I said, there were only 3 cases. One of them was because of the internet, because it actually wasn't listening to us, but because of the headset. 2 students, they don't want to be paired with online students. So what we did, we moved those students to the on-campus only lab, and we put someone else who is happy to be paired with the online. So that's these are the 2 only concern we have. All the rest, we were visiting the students, they were happy, they were also sharing their Facebook account together. They become friends as well. So it's we show like a type of interaction, really. They really like it. But yes, we had these 2 issues. I still remember these.
Would you say the interaction between online and face-to-face was better than 2 face-to-face students working in a group? That's what it sounds like from what you're saying.
No, I said it was better than, because some labs, they were running by 1 lab demonstrator with 20 students online, and the lab demonstrator was sharing the hardware with 20 students online. So what I mean, the interaction between any students from those 20 with the lab demonstrator wasn't as good as when you have students in the breakout rooms and they have 2 lab demonstrators visiting them.
Okay.
Yeah, of course, face-to-face, even the result survey, the students who were on campus, they mentioned that 97% of them, they were really satisfied with the interaction with the on-campus lab demonstrator. Because when you are online and in breakout rooms and you need a help, and you ask for help for the online lab demonstrator, because you can't see him, you don't know what he's doing. Actually, he's maybe busy in another room. So you feel he's still like he's not listening. He's not. He didn't note your request. That's why it was 90%. They said 90% were all right. While if you are on campus and you want to help from the lab demonstrator and you can see he's busy with someone else because you can see him, you know that he will come to you straight away after he finished. So you know that he's busy. He's not like. You don't want to be like isolated in the breakout rooms. That's the difference between to be on campus and to be online. Of course, on campus, like from the results, we can say on campus was much better than to be online. But just a way of increasing the communication channels, because we had also an issue with students. They were complaining that they don't have enough interaction time with the lab demonstrators because he's running 20 students online, and it's really hard. But for put them in the breakout rooms, students, there's 2 students chatting together, and there's 2 lab demonstrators walking around, one online, the other one physically on campus.
So from the demonstrator point of view, how satisfied were you? Because you just said that, when students are online, like mostly my concerns are with the online students, because on-campus students, you can see their face, you can see exactly what they're doing, and you can get a feeling like whether they're understanding or how they're going. But it's a bit challenging with the online students, because I understand that they would show the simulation results to the online demonstrator, but how did you feel about it? How satisfied were you as a demonstrator?
I run only the first lab for each session, just to make sure that the lab demonstrators and students understand this type of mixed mode. But I have been visiting all the labs. It's completely different, of course. To run the lab physically, much better to run it remotely. By the way, it's about 99% of the students were sharing their webcam, so they turn it on their webcam. We don't push them to do that. We told them only when you want to share the results, you need to open your webcam to share the results, or just share your screen. But actually, all of them, they were happy to open the webcam. They share that. But the online, the challenging, of course, there's some, because of the internet, you are dealing with students behind the screens, trying to contact them. Some of them, they have problem with the internet. To be online, lab demonstrators not like to be on campus. To be online, like you need visit from room to room. You don't know what's happening. When you are in the one of breakout rooms, you are completely isolated from the other breakout rooms. It's not like when you are on campus and you walk around, you look for all the students in front of you. So yes, it's completely different, but it's a way to make things better than other way. You know what I mean? So it's much better to have only I'm a lab demonstrator. Like for other subject, we have the lab demonstrator running with 20 students, and he or she is sharing the hardware with the students. So one guy talking to all the students, Most of them, they're not turning their cameras on. Some of them, they're not even there after you finish the session.
Yes.
Yeah, we finished. Maybe they are going shopping or shop.
Yeah.
You know what I mean? So
Exactly.
it's not.
Yeah.
But in this one, for English 104, the good thing is like all students, all students were turning their cameras on. So, and the interaction between students were really good between the on campus. And also it's not to be like, you have someone to work with, to discuss with. That's another advantage as well. Although it's through the internet, but.
Asa, I missed your talk. Sorry for joining so late. Actually, I don't know whether I will share something, because right now I'm teaching one unit. It's called IoT system design, Internet of Things system design. It's fully prax based. I did not know till the first week that I have some online student. And to be very frank, I'm failing very well, because one of the things which I feel that you could do good justice to online students if you have the right infrastructure. So I prepared the unit basically 100% prax based. And then I realized that for simulating Internet of Things, you need some special software, and they are not available in our university. So when we ordered, it was not very cheap. So effectively, we did not get that. So I have 7 students, and I really don't know what to do. And this is week 8. So you could do justice with the online students, provided you have the right infrastructure, which will be parallelly good for the prax what you are conducting for the on campus. So otherwise, even though we talk a lot of things, but it does not really help much.
So Subhas, what Faisal presented to us today was basically all you need is a web camera and Zoom. And the online students were engaging with the students that were in the practical, doing it at the same time.
Yeah, I understand that what you could make them engage, but what happened, because if one group does the hands-on, other group will not be too happy seeing that. That's the thing.
Thanks for that comment, Subhas. And I guess, you know, nothing is perfect. What Faisal demonstrated seemed to have kind of worked, been good enough for the troubling times. I will be, this presentation is being recorded, and I'll give it to you so you can go back and see the full presentation.
Yes, we'll do. Thank you, Sadar. Thank you.
No problems. I'd really like to hear some remote implementations, if anyone did some remote implementations, so we can learn about your experiences. Anybody else have any problems like Subhas has just mentioned? Sounds like not. Any last questions then?
I might just throw one out there.
Excellent, Peter.
Peter Jones from University of Sydney. Very interesting, Faisal, hearing the experience that you've had. It's very, very similar to what I experienced with a couple of our first year labs. We ran one of the labs with about 500 students first semester last year in a pure online mode, where we just videoed the demonstration of the labs and attached some sort of post-lab quizzes to that. That was basically all we could do with the lead time that we had. We're now running that lab this semester in a mixed mode, very, very similar to the way you've been running. Our experience has been slightly different. I can think of probably 2 or 3 significant differences. we've had a great challenge getting students to use webcams. So it was really interesting to hear that your students tend to be embracing that much more. Possibly one of the differences is we're running group sizes of about 4 or 5. So we can obviously we can only run one camera in the lab, but and I guess it's difficult for the students to on campus to share that. So we're finding that the online students who aren't using cameras just tend to get forgotten, tend to get left out. So that's a challenge for them. Just trying to think what the other things were that I was going to mention. In terms of Zoom breakout rooms, we've started a similar process of having, because we've got about 50 students in the room and probably about 30 online. So we would have a couple of demonstrators in the room, and we've started to allocate a dedicated Zoom demonstrator, and that's working well in terms of keeping the online students engaged. We had exactly the same challenge as you, that when the Zoom tutor goes into a breakout room, they effectively become isolated from all the other online students. So we've made a slight change, and that Zoom demonstrator tends to stay in a main room. And if the online students have questions, they come out of their breakout room into that main room. So if they pop out and they can see that there's already 3 students waiting to be assisted by the demonstrator, they get a bit of a feel for the time that they'll have to wait. So there's not that wondering why there's not an instant response. We're also trying to encourage the remote students to get their in-campus student to stick their hand up as well, to get the attention of the in-room demonstrator. But it's definitely been a balance. The third thing I was going to mention was that we also had the enrolment option where students could choose to enroll into the on-campus session or the online session. In terms of the local students, our experience was that, I don't know, put a percentage on it, maybe 10% of the the local students who opted to enroll in the online mode realised by about week 2 or 3 that the experience was going to be much better on campus. And so there was a great move to try and get positions on campus for them. We didn't have so many who opted the other way around.
Well, that's great, Peter. So good to see a similar strategy implemented. And I think from the similarities between the two, you can kind of work out what worked and what didn't. Maybe Faisal and yourself might think about getting your data together, synthesizing that and publishing a paper and sharing it with the community.
Yeah, thanks, Peter, for sharing that. It's really great. The only thanks for sharing this information. The only maybe what would you do when when your students get out from the breakout room? That's a good idea to go to the main room. But the other challenging that we are facing is we have the pre-assigned breakout room. So when the online demonstrator want to send the students to breakout room, he or she just click on one button, they will send automatically. But when they get back from the breakout room, it happens sometimes to us, because we have a big screen in the lab. So the on-campus, he will notice if there is someone attend late and the online lab demonstrator is in the rooms, or if someone popped out from the breakout rooms to the main because he needs to be sent back. So the on-campus will see that, but the challenging is to remember, students sometimes they don't remember which breakout rooms they are in. So that's another challenging as well. So that's why I asked all the lab demonstrators to have a list of each lab, each breakout rooms and the name of the students. At the beginning, we were wasting some time on that. So what's your room? I don't know. Then you need to go and find out. So that was maybe a challenging, especially with a big size lab, 50 and 30. It's really big. It's really, that's another challenging as well.
Yeah, we've had the same experience, definitely. We pre-allocated all the students to groups and had all that pre-allocated to breakout rooms in Zoom. One thing that we made sure to emphasize at the start of every lab, once the majority of students had joined, was we asked them to change their display name in Zoom to append their group number on the end. Then they only need to remember one group number. The demonstrator doesn't need to look everyone up. And then when the students do pop out of their individual breakout room, it's really easy for the demonstrator to pop them back in without needing to look it up. And I think the first couple of weeks takes a little bit for people to get used to, but generally students get the idea and just automatically do that.
Yep.
And I think too, if they're logging in from the same computer, they can log in with the previous Zoom name anyway, so they don't have to remember to change it all the time. But that worked well for us to save a little bit of work.
Perfect. That's a good idea. Yeah.
But yeah, I'll be really interested to look back over some of the slides on the tools that you used for evaluating, because we probably don't have so much in the way of any hard data. It's more experience, and we're in the process at the moment of condensing that down into a bit of a lessons learned, I guess, that we can share with other units of study, just to try and help each other out. So it was really, really interesting. I was smiling so much as you went through your presentation, the various challenges.
Okay, if there's no further questions. No, thank you everybody for attending this. I hope you took something out of it. My email and Faisal's email is there on our profile, so you can have a look. Send us an email if you want to talk further. Happy to work with anybody, and I really appreciate your time from your busy schedules. Have a great Friday afternoon.
Thank you.
Have a nice weekend to all.
Thank you. See you all.
Before everybody just pops out, well, thanks to Sasha and Faisal for this nice presentation and sharing your experiences, and to everybody for this interactive session. And please write to us if you would like us to arrange anything in particular, like any particular workshop or any such sessions in the future. Please write to us to me as like what you want education chapter to arrange for you, like something that would be beneficial for all of us. Please write to me. You would have my email address on the, you must have registered for the event, and you would have my contact details there. Please write to us what you want us to do in future. And thank you very much for joining today.